Hello everyone, here I am back again for another video. This is the 9th type, but technically the 10th video, and here it is also about functions that we're going to talk about. Some more about functions. Functions are very important, so I'm gonna be indulged on function also in the next video, probably 2 more. It's very important, and there are a lot of things to learn in functions. Okay, so this is a part 2 for the introduction to functions, and here we're going to talk about function declarations, default parameter values, and about inline functions. Okay, it's not going to be long, it's going to be a short video. So in our previous video we wrote a program that was something similar like this. It had an addition function that took 2 values as an integer. It returned integer. We called addition from main function. I told you how it worked. I hope you understood that part, because that's very important. Without that, you will not be able to proceed on this video. You will not be able to follow it. So make sure you understand what I was talking about in my previous video. So here, basically, I'll just summarize that. Addition is being called, and addition is another function that returns an integer value, and we store that integer value somewhere, or maybe just see out that value, whatever you like. So that addition a, b, this little part here act just as a regular variable, because it returns a variable, this function right here. So but a is being copied to e and b is being copied to f, and it manipulates that e and f, and e and f does not exist for main function, it only exists for addition function. Okay, that's how we did it in our last video. But and also, so it follows logically, are you able to call another function from a given function, right? And you can do that in C++. It's pretty straightforward, and just like how you call the function addition from main function, you can call another function from addition function and pass the value. So here I have used a and b everywhere just to show you that a and b that was inside the main function is not same a and b as it is in addition function, and this a and b is also not same as that is here in another function. Okay, this a and b can have different values than this a and b in addition function than these values in main function. Okay, so here we have called another function a, b, and we have passed a, b to that another function from addition function. Okay, so far so good, but you might have a question. You might or might not, it depends upon your observation. Why are we declaring these functions above main function? Main is a main, it should be at the top, right? Or why are we not declaring another function below addition function, right? So that's the question. So if you do that in C++, you get a compiler error. Okay, if you do something like this here, if you say if you have a main function that calls addition a and b, that will be fine. It will look for addition, because as I told you, a compiler looks to the code line by line. Okay, it goes from top to bottom. Okay, so compiler, since it have called for a and b, compiler knows that okay, there is a and b, I know it, so it goes up here, it calls, and now here it is asking for another function a, b. Now what's going to happen is that we have declared another function a, b after addition function, so compiler is going to complain you that there is no another function before addition function. Okay, another function needs to be top of addition function. Okay, that ordering is very important, but there is another way where you can make this ordering not so important. That is called prototype declaration. I hope you understood what I mean by the ordering of this function. You can put main function up here, put these other 2 functions down there, but the problem you're going to have is it's not going to see that there is this function that you can call. Okay, since the program goes from top to the bottom, if you have int main as the top and you have called addition a and b, right at the top it's going to say that I haven't encountered any addition a and b before, so there is no addition a and b. That's what it's going to say. Okay, so to get rid of that problem, we use something called a prototype declaration of a function. And this is how we do it. We just say that, okay, I'm going to have a function, I'm going to have two functions, another function that's going to have int a, int b, and another function called addition that's going to have int a, another integer b. So basically you can also say another function int and addition int. You don't have to say that it's going to be a or it's going to be b. You can just say that, okay, I'm going to have this function and it's going to take this kind of arguments. That's all you're going to be declaring, and you put semicolon after that. Now what happens after that is, after you just declare that, okay, I'm going to have this function, it can be after main. So the compiler is going to say, okay, there is this function, and if I encounter any call to this function, I know that there is this function, so I'll look for it after main. Okay, that's what compiler is going to think. And after you come for addition here, it's going to say, okay, I have seen addition prototype declaration, and a and b both are integer types, so there should be a function called addition somewhere down there. So it goes down here, finds addition function here. Now it calls for another function. It's going to say, okay, I have also seen a prototype declaration for another function, so it should be somewhere, and again looks for it. It finds it right here, and does something, returns, or whatever you want to do it, and whatever you want for it to do, it does that and just returns that value. Simple enough. I'm going to show this in example. I'm going to write a program after we're done with the slide, so it's not very long, just to show what I mean about all this. And this is very important, you learn about prototypes. Okay, a lot of times, there are situations when you do not know what function needs to come before what function. When you have long piece of code, you might have a lot of function. By the way, function is not asked by compiler, it's optional, it's more like a privilege, and I very strongly recommend using that privilege. It makes your life a lot more easier as a programmer. If you don't want to do it, it's your choice, but don't blame anybody else for yourself not understanding your code later when you want to have a look at it. Okay, just that simple. Functions are very important. You can just divide your codes into different parts that you can call. Okay, and also while declaring a function, you can define a default parameter value, in case if we know that some value may have a certain specific value, or we may not pass a certain value to a function, then you can declare a default default value for a given parameter in a function. Okay, so but you can just randomly say that, okay, this is going to be default, just use it. That's not going to happen. What you can say, as you can see here in the examples, how we define the default values is that if I declare a int multiply prototype, and I say int a, and another is going to be int b equals to 5, then what you can do is, when you are calling this multiply function, if you pass only one value of integer type, then it's going to assign that value to a, and if it sees that it does not have a second value, then it automatically assigns value of b as 5. Okay, and it does whatever you want to do with a and b inside this function. But if you send two values to multiply, let's say if you send 11 to a, and if you say multiply 11,7, it's going to say that, okay, a have a value called 11 and b have a value, so I'm not going to use this default value, I'm going to use whatever value they have sent me. You see, it just goes like that. Okay, just a default value in case you are not certain if you're sending how many parameters, and if you know that this default value works for a function, then that's how you do it. Okay, here are some more examples. You can just say give all of them as some default values, just in case if you don't pass anything, it uses something, but you cannot do something like you cannot define default values like what I have done in this third example. Here you cannot define default values to be any random parameters. It have to be on the rightmost, it have to be ordered in the rightmost part. All the default values, there should be no values that does not have a default value after you have declared a certain value as after you have given a value a default value. I'm not sure if you are getting what I'm trying to say here, but these two examples might shine a little more light to it. here I have a declared b equals to 4. I've declared that the value of b is going to be 4 as default, and then I have said that c needs to have a value. You cannot do that. If you want to declare b equals to 4 as a default value, declare it after you are done with the required values. Okay, just order them in the rightmost part, and you should be okay with that. Otherwise your compiler might complain that you have missed some values inside the function. Okay, so that's a default parameter value. And now there's also something called the inline functions. We use a inline specifier. We specify that this function is an inline function. What that means is it indicates to the compiler that the code generated by the function body is inserted wherever that function is called, as opposed to the regular functions that compiler generates the code once and we make regular call to it. Okay, the difference between these two is you may not see any difference, being your computer really super fast, but it's less overhead time in running those programs. Okay, just use inline specifier. It's just like regular function. You just declare that this function is inline function. Just, as an example, I have said inline int addition, that addition function is going to be inline function. That means that whenever you call addition, it's going to just put that piece of code generated by that addition into wherever you have called it. Okay, and you don't have to call addition as inline addition when you're trying to call it. You just call it regularly like any other function. It's nothing different. Just add inline, then that it makes it inline. Okay, so this is all about that I wanted to talk in this particular video. And let me just write some programs about what we just learned to be a little more clear into it, and hopefully that will help you get more idea about what I was talking about. So we had this test.cpp file earlier, so let me just write this real quick. So we have this int main function. Let's write a little more program that you don't know what is going to come before what. Let's say a program that's going to call for something. Okay, let's make a odd and even program. Okay, let's say I'm going to have int a. All right, let's get something from the user. Okay, so before that, let's just enter a number. In a, after a user enters that function, we're going to check if this function is already, the program that I'm writing, you might be able to write it in, I don't know, 10% of the line that I have written, but just to show you. Okay, may not be very efficient. Just to show what I mean by prototype declaration, why is it important. So let's say say we have a function called odd, and we're going to send it to a. Okay, now let's just say that this function is going to be void. It does not return anything, and I'm going to say odd. Okay, and it's going to take an integer value a, and I'm going to say if a modulus of 2 double equals to 0, right? If it is let's say not equals to 0, then we can say cout it is odd number. Okay, or else what I'm going to do is I'm going to say even. Okay, a modulus of, I'm just going to send a to it, and let's write another program, even int a, right? Now if a modulus of 2 double equals 0, similar to what we have for the odd function, except that it is true when it is even. It is even number. Okay, and L. All right, and else, let's just say odd. If it is not even, then it's going to say it's just going to call for odd function. Here you can see why prototype declaration is important, because from here if we call odd a, and if you also want to call even a, then either of these two, we don't know what function is going to be called first. Okay, that means that we're going to have some problem with the program. Okay, test. Okay, so you see odd was not declared in this scope. Okay, and that's the kind of problem that you're going to have in situations like this. So what we do, as I told you, declare these as prototypes and use this function later. So now you can see it have two function, odd and even. Now compiler doesn't complain, it's happy. All right, now if I say test, if I enter number 5, it's the odd number, it's the odd number. We designed program it to say it twice. So you see why prototype is important. That's why. Okay, so thank you for watching. Please visit my website. You can join my website, contribute to forum, and have some more knowledge about programming there. There are some practice quizzes, or there will be. And yeah, thank you for watching.